Welcome to the CIT 260 final presentation for the Object Rotation class with me, Casey Shear. We're going to be starting off with talking about variables, the static variable. Memory for a static variable is created only once in the program at the loading of the class. These variables are set with the static keyword. You access them with reference to their class. Here we have an error view that has some static variables with on line 20, public static void display, which we wanted to make a little nice, concise outline for our error message that we could add just a snippet to, so we could use it for any type of error. So no matter what we do, that part of the error message will always be the same. And then we'll add a little error message variable in there, which you can see. That'll add that little last snippet based upon what error message we have. This makes it really easy and concise and simple. We can make our error message work for any type of situation. Here you can see the main menu when we go to put input, such as 1, which isn't a valid one. It displays the error message and gives that little extra snippet of invalid selection, try again. Here in the switch for our main menu, if you don't enter N, R, H, S, or Q, it runs the default switch part, which will run that error view.display, and then also add on to it the invalid selection, try again. Really nice and concise. Next, we have non-static variables, sometimes called instant variables. Memory for these variables is created when the creation of the object of the class is created. These do not use the static keyword. The big difference between static and non-static is that the static stays the same and non-static variables will be changed or adjusted along the way. Here we have our player class with our on line 19 private string name, a variable we want to change. And with it, since it's private, we have some getters and setters to access it. Here we have part of our do action that will set that player's name, and with another part of it to actually grab input from the user. Here on our display next view, after that's all done, it will then display a welcome message with the player's name, which we'll show you here. So in the beginning, it asks me, please enter your first name, super cool dude. Name I entered. It says, welcome to the game, super cool dude. If we had another instance of that where it asked us again, please enter your first name, right after that, and we've typed something else, KCJ Shear, then I had to display the message, it would say, welcome to the game, KCJ Shear, right after that, all within the same process of the game. So you can change and adjust it as you go. Next we have arrays, or rather just array. It's a simple fixed size array that we can create. Once created, it will always be that size, or rather always have a set amount of entries. Array can contain primitive data types as well as objects depending on the definition of the object. Here we have our create actor list, which will grab all of our alien actors and keep them all in one nice list to access. We want to implement it this way because we only had a set amount of alien actors, one alien type for every planet. Therefore, we were never going to have more or less. You just have these ones and that's it. We wouldn't need. So this works out really well. However, if we wanted to implement more aliens as we go along, we wouldn't be able to do that unless we had an array list. Array list is a dynamic sized array that can change how many entries it has. You can add or remove entries from it. However, they can only contain object entries. We don't have any array lists, but here's an example of what one might look like. This one has 27 entries in it, but if you wanted to add more to it, you could easily do that. I also want to talk about enums, enumerations. Even though we didn't have it in your game, I'm going to give an example of one we were thinking of beforehand, just to kind of show how that would work. But it's a special Java type used to define a collection of constants. It's a special Java class. It can contain constants, methods, and some other things as well. We were originally going to implement a weapon system, with each weapon having a damage type, such as explosive, ballistic, energy, or some other things. And then our aliens were going to have a weakness to a certain damage type. So Martians might be weak to, let's say, explosive, while Venusians might be weak to energy. And so when you use that certain weapon, it might have special effects or do more damage against aliens that are weak to it. Originally, we were thinking of doing this, we're going to have to implement variables and constants and things for every single weapon, every single alien, and it kind of go overwhelming. And then we came up with, we could use an enum for this, where we would display as constants each different damage type. So we'd have energy, ballistic, explosive, and we'd access that enum to be able to get those really quickly, make it a lot less code, a lot easier, kind of keep it concise. But we end up dropping the system overall for other reasons. Next, we have loops, specifically the for loop. It's a compact way to initiate over a range of values. You initialize the loop, check to see if the conditions are true or false, continue on through and increase or decrease, or conditions aren't met right, you might exit out, but until those conditions are met to exit out. Here we have a trophy control, which sorts our list of trophies and displays it to the user. Here, as long as I is less than the trophy size, it will add to it and continue on until it does, in case it exits out and then prints out to our user later on. Next, we have the for each loop, also known as an enhanced for loop, which came out in HTML5. It's a streamlined way to handle each element when processing loops, such as all the elements within an array. For here, we have our location scene with all of its locations, and each location has a location name, planet depth, surface hardness, which we have getters to grab those. So that's a lot of information, especially if you have like over 20 or 30 locations. It's like 90 different things. So this for runs through all of those, and it's some other code's going to print out that to the user. Therefore, it processes each individual part, but still keeps it efficient and streamlined. For each is pretty nice. Next, we're going to talk about exceptions. So most games, when you're designing or even when you're running it, are going to have errors, issues, problems. No one wants that. Most times you work through those until you get the game running right. Well, it can still have issues. Some errors you can only find when running your game. Other times you'll have errors which you don't really want in your game or didn't think would happen. So you want to try and get those out as well. With a throw, you would interrupt the object and throw out any remaining part unless it's handled right. Therefore, your game doesn't crash. You can keep on going. With catch, it'll try and handle the issues with a series of different exceptions. It catches the issues and continues on. So here we have a class that has a part of our code here. This would handle different input integers from our user. On line 44, it has an if statement, which basically checks to see if the number is between 1 or 10. If it's not, it displays an error, continues on. On line 49, we have a catch, because with this being integers, we want to make sure that the person doesn't put an A or a semicolon or an @ sign, which would cause our game to crash, because you can't compare those numbers. They don't have a value like a number. So instead, we would catch that and display an error message instead, which we talked about our error message, and then add the part onto it, place it between 1 and 10, and continue on. And then down below, we have a while that runs through and over until you do it right. Therefore, you don't have someone that does something stupid and breaks your game. You have to start all over. Here we have the do action for that with our drill field for our resource control that works with that. And in our game, when it asks us what drill power we use on this planet, and we try and enter number between 1 and 10, and we enter A, it's going to display that catch and the error instead. Really nice. If we entered, let's say, 27, it would do the if statement instead and catch it that way. But if we entered A, semicolon, plus sign, or something other funky else, it'll catch it and continue our game. Way to go, error message. Next, we have streams. Streams are used sequentially to access a file. An I/O stream are rather an input source or output destination. Character streams is used to read, write data character by character for Unicode conventions, like in a text file. Byte streams process data byte by byte, which is 8 bits, 8 ones and zeros, like in a raw data file. Interesting little tidbit here, and we talked about bytes with 8 bits, 8 ones and zeros, 8 binary. They actually have a definition for half a byte, which is 4 bits, and that definition is called a nibble, which I think is hilarious. Next, we'll show you in our code our character data to an external file. We've showed you a little bit before, but we'll run through all of it. We have our print location report, which will display a message to our user, what kind of sets them up what to do. It'll get input from the user. It'll try and do some stuff in case that's not right. It'll then create some objects for us to run all the locations through to be able to display those. On our out.print lines, it's going to organize in that text file how those are displayed instead of being just one big long line, so it looks actually like a report. Continue on down to line 165. It has our for each loop we talked about before. That'll run through each different element and display it right. And then once it's all displayed, it flushes it out. We're all good to go. And then obviously, if it works right, it'll success. You did it right. Nice way to save to an external file. I have the final game for you. Let me pull it up real quick. I just have it as a different media source. So when our game starts, when you run it, it'll tell us you have awakened to find yourself on Triton, one of Neptune's moons. Goes on to explain you've crashed and you get home and some other stuff like that. Let's enter a name. We'll call it let's do a super cool dude. Nice name. It says, welcome to the game, super cool dude. We hope you can return to Rexburg. We're actually not getting back to just Earth, but to Rexburg, Idaho, because we're late for class or something. So first we can kind of go through some stuff. We go through the help files, which kind of tell us like the goal of the game, that you want to return to Earth, Rexburg safely, and you do that by using the fuel and some other aspects. Learn how to move through space, provide a map, and so on and so forth. How to view your fuel. Your fuel is very important if it's less than 20, so on and so forth. And then we can return to the main menu. You can save your game. We'll save it as super txt. Why not? We could also get and start a game. So we'll get, and then it will run from there. So this is the game menu. Here we have with it. There's some different options. We'll kind of run through. So we have the alien menu. We can use A to get to that. You can encounter aliens. You can pass by them. You pass by the alien safely. You can also answer a question for your alien. Alien trivia, is the sky blue? Yes, it is true. Go back to the main menu. Cool. We got some trophy and some fuel. And then we go back to the main menu. We also have our location view, which we can earn trophies. It calls the earn trophy view. We can drill for fuel, which we've shown a little bit before. Basically, you want to drill for fuel. You'll use the drill in your spacecraft. Basically, how much you want to power it, range 1 to 10. Basically, no power, a lot of power. And this is going to compare towards the planet depth and the surface hardness. So you want to drill hard enough to get through the planet, but not so hard that you drill past the field. So we'll say A. Oh, right, A is not a good response. You can compare that. Good thing our game didn't crash. Instead, it caught the error. Okay, we'll put 27. That's really good power, right? Oh, again, an error. We don't want that. So instead, we'll put 7. You can also view your fuel, view the trophy count, and then return back to the main menu. And then we also have the trophy menu, which you can view all your acquired trophies. Apparently not. It was working just a second ago, but that's fine. We'll just run it real quick again. Ignore that part. So super cool dude. Start new game. And then we were on the trophy menu. So we'll go to fuel. In the fuel you can view how much, yeah, we're at 100%. And that's our game. We'll close that down and go back to thing. Inclusion, thank you. Just overall neat experience we had, and I leave you with a true joke. Thank you.